Ever wondered why there is so much attention on Mars and not on other planets? Well, all that is about to change with NASA's plan to revisit Venus soon. Venus is the closest planetary neighbor to Earth, and NASA has chosen two new missions there. The missions, which are part of NASA's Discovery program, seek to understand how Venus turned into an inferno-like world, even though it shares so many traits with Earth and may have been the first planet in the solar system to support life, complete with an ocean and atmosphere similar to that of Earth. As part of the agency's Discovery 2019 competition, 4 mission designs were chosen by NASA in February 2020 as the final 4. The 2 missions were selected through a competitive peer review process based on their prospective scientific value and their viability of their development plans. Currently, the project teams are working on completing their requirements, designs, and development strategies. NASA gives each mission about $500 million for development. Each is anticipated to launch between 2028 and 2030. The missions. The first mission is called Da Vinci Plus, to comprehend how Venus's atmosphere arose and evolved, as well as to discover whether the planet ever had an ocean. Da Vinci Plus will measure the atmosphere's chemical makeup. The mission's goal is to understand better why Venus's atmosphere is so hotter than Earth's by sending a descent sphere through the planet's dense atmosphere and taking exact measurements of noble gases and other elements. In addition, Da Vinci Plus will deliver the first images in high resolution of the distinctive tesserae geological formations on Venus, which resemble the continents of Earth and may exhibit plate tectonics. The Da Vinci Plus mission would be the first American-led expedition to Venus's atmosphere since 1978, and its findings might change how we think about how terrestrial planets develop both within and outside of our solar system. The lead researcher is James Garvin of the Goddard Space Flight Center in Greenbelt, Maryland. Goddard offers project administration. The observations of Da Vinci will highlight Venus's dense carbon-rich atmosphere in contrast to the other mission. Da Vinci, whose launch is planned for 2030, consists of 2 parts, a primary spacecraft and an atmospheric probe that will spend an hour coasting to the surface. Alpha Regio is the subject of research presented by Margaret Dean, a graduate student working with Gilmore at Wesleyan University. Da Vinci's probe will land there. Dean described the environment where she is working to dissect a web of ridges, troughs, and other structures ahead of the probe's arrival as, quote, quite frightening. The second is called Veritas. To ascertain Venus's geological past and comprehend why it developed so differently from Earth, Veritas will map the planet's surface. With a synthetic aperture radar in orbit around Venus, Veritas will map surface elevations throughout almost the whole planet to produce 3D topographic reconstructions and determine whether volcanism and plate tectonics are still active on Venus. Veritas will also map infrared emissions from Venus's surface to map the planet's mainly unknown rock type and identify whether any active volcanoes are emitting water vapor into the atmosphere. The lead researcher is Suzanne Smirkar of the Jet Propulsion Laboratory of NASA in Southern California. JPL offers project management services. The Italian Space Agency and France's Centre National d'Etudes Spéciales will contribute to the radar and other components of the project, while the German Aerospace Center will supply the infrared mapper. NASA's plan. According to Thomas Zerbuchin, Associate Administrator for Science at NASA, we're stepping up our planetary science program with a focused exploration of a world that NASA hasn't visited in over 30 years. We're starting a new Venus decade to learn how an Earth-like planet can turn into a hothouse using cutting-edge technologies that NASA has built and improved through many years of missions and technology programs. Our objectives are serious. Understanding exoplanets, an exciting and developing area of research for NASA, goes beyond simply understanding the evolution of planets and their habitability within our own solar system. In addition, Zerbuchin stated that he anticipates significant synergies among all of NASA's science initiatives, including the James Webb Space Telescope. He expects the widest possible cross-section of the scientific community to exploit the data from these missions. Tom Wagner, a NASA Discovery Program scientist, said, "It is surprising how little we know about Venus, but the combined results of these missions will tell us about the planet from the clouds in its sky through the volcanoes on its surface, all the way down to its very core. It'll be as though we've discovered the world again. NASA also decided to perform 2 technological demonstrations in addition to the 2 missions. The Deep Space Atomic Clock 2, created by JPL and supported by NASA's Space Technology Mission Directorate, will be housed on Veritas. This technology will eventually make it possible for autonomous spacecraft maneuvers and will improve radio scientific observations. Since the termination of NASA's Magellan mission in 1994, Veritas, which is scheduled to launch in 2027, has been designed to peep through the planet's dense clouds and provide scientists with their first view of the Venusian surface. The spacecraft's equipment will provide information on the planet's innards, geologic activity, and rock composition. The great foundational data sets that Veritas will create, according to Smirkar, will just tell us so much about Venus and lay the way for the decade of Venus and all the interesting investigations that will be addressed today, as well as hopefully many future missions. The Venus Emissivity Mapper, one of the Veritas instruments, will have a near-twin fly on the ESA's mission Envision, which is scheduled to launch in the early 2030s. Helbert stated during his presentation that the 2 devices will work together due to their staggered arrivals, especially as Venus is the only inner planet whose rock types have not yet been mapped throughout its whole surface. The instruments will also be able to determine whether active lava flows are present on Venus's surface, since such structures will glow in contrast to neighboring cooler rock and give the clouds above a sinister glitter. The Goddard Compact Ultraviolet to Visible Imaging Spectrometer will be housed at Da Vinci Plus. CUVIS will use new freeform optics-based equipment to perform high-resolution measurements of ultraviolet light. With the help of these data, it will be possible to identify the unidentified UV absorber that absorbs up to 50% of the solar energy entering Venus's atmosphere. The Origin. Since its inception in 1992, NASA's Discovery program has assisted in creating and using over 20 missions and sensors. The 9th Discovery program competition includes these missions. The ideas were picked from submissions made under NASA in 2019. The Discovery program's Planetary Mission Program Office at NASA's Marshall Space Flight Center in Huntsville, Alabama, will oversee the chosen investigations. The Planetary Science Division of NASA's Science Mission Directorate is where the Discovery program carries out its space science research. The program's objectives are to frequently offer chances for principal investigator-led planetary scientific research that can be completed under a not-to-exceed cost cap. Why Venus? The planet has a surface temperature of 440 degrees Celsius to 480 degrees Celsius, and its average distance from the Sun is 180 million kilometers, which makes it 38% closer to the Sun than Earth. Its diameter is 12,104 kilometers, and Earth is just 5% wider. With a volume of 928 billion kilometers cubed, Venus could fit inside Earth 1.1 times, and its gravity is 8.9 ms squared, 90% of Earth's. One solar day on Venus is the equivalent of 243 Earth days, while one solar year is 225 Earth days. Its atmosphere is 96% carbon dioxide, 3% nitrogen, and 1% other gases. Scientists, including co-founder of the Planetary Society Carl Sagan, have hypothesized that life may already exist in Venus's upper atmosphere, which is located about 50 kilometers above the planet's surface and possesses temperatures and pressures similar to those on Earth. Over half of the solar energy is absorbed, thereby enigmatic black spots. Scientists claim to have discovered phosphine, a substance closely related to life, in Venus's clouds in 2020, while the validity of this signal is still being investigated. Venus was once a world that might support life, but we don't know what caused it to become the horror it is now. Scientists can learn about the evolution of Earth-like planets and the circumstances of Earth-sized exoplanets by studying Venus. Venus also aids in the modeling of Earth's climate and serves as a sobering example of how quickly a planet's temperature may change. The importance of understanding the world around us can never be underestimated. Let's hope something good comes out of these missions. Let us know what you think in the comments below.